Here we have three facts about a function f, and we're trying to match that function to one of these graphs. Okay, we're going to start with the fact that f prime of -1 is 0. That just means there's a horizontal tangent line at -1. Now this is going to come as a disappointment to you because every single one of these functions has a horizontal tangent line at -1. So that information is pretty much useless. The second piece says the second derivative is positive, which is to say the graph is concave up as opposed to concave down on the interval from -infinity to -2 and on the interval from 1 to infinity. The third point, like I said, says that the graph is concave down on -2 to 1. So we want to find graphs that match this description on these intervals. All right, so -2 probably occurs around here for this function, and here, and here, and here. Because after all, -1 is that point where we have that horizontal tangent line. Okay, is this graph concave up from -infinity to -2? I think I see a smile right there, so I do get concave up from -infinity to -2. Then it's concave down from -2 to this point, but then it remains concave down from from +1 to infinity. And we want it to be concave up from 1 to infinity, so it can't be this graph. Let's keep going and find that we have this graph initially is concave down. Well, that violates statement number 2. We want it to be concave up on the interval from -infinity to -2, so it can't be this graph. Let's look here. We want this graph to be concave up on -infinity to -2, and yet we've got a sad face, so this is concave down, so it can't be this answer choice. Let's just, for completeness sake, verify that this is our correct answer. Is the graph concave up from -infinity to -2? Yep, I see a smile there. Is it concave down from -2 to +1? If I put 2 dots here, I see a frown, so that is concave down. And then if I put 2 dots here from 1 to infinity, I see a smile, satisfying the quality that we have concave up from 1 to infinity. So this is our answer.